Hi, good afternoon. I am Alvin, one of the researchers from Project GUHeat. Today, I will be talking about the future urbanization scenarios in Baguio City with focus on the impacts and mitigation. So during the national webinar, we have discussed about the possible causes in the formation of urban heat islands, one of which is the rapid rate of urbanization. So in our country, by 2010, the level of urbanization is 45.3%. It is expected to rise up to 56% by year 2050. So in our capital region, the level of urbanization is already full. So full urbanized na siya. In other urbanite islands in the country, the level is also alarming, one of which is our site in Baguio City. So in these photos, we can see the changing landscape of the Session Road from the 1970s up to the present. So in the second photo, we can observe a greening feature initiated by the government or by the city government. And we can also see here the center island or yung median strip na tinatawag with planted vegetation. However, population density is still increasing, and we have observed both horizontal and vertical expansion of buildings. So based from the study of GUHeat and Stokke Moriyama and Gonzalez, the high rate of urbanization in Baguio City is mainly due to land cover changes and urban sprawl. So between Baguio City and surrounding rural areas, the surface temperature difference is 4 degrees Celsius up to 8.2 degrees Celsius from 1987 to 2015. So according to the GUHeat studies, we have found out that the land surface temperature is increasing with a rate of 0.11 per year. Also, the hotspots were detected inside the central business district. So in Baguio City, this trend in the land surface temperature will continue if similar rate of build-up expansion will take place. So therefore, it is important to model possible urbanization scenarios in the future for us to draw the possible or the necessary mitigation actions. So before we go to the current or the future scenarios, it is important to have a base scenario. So in this case, the current scenario. So our site is Session Road, located to the right of your Burnham Park. So bakit pinili natin yung Session Road? One, it is located within the Central Business District or CBD. Maraming turistang bumibisita sa site, especially during the summer vacation or yung dry season natin. There are ongoing and future projects by LGU and universities like UC. There is mixed environment, and it is attractive to tourists and business, so it is prone to further urban development in the near future. It is subdivided into two, Lower Session Road and the Upper Session Road. Majority of our studies were conducted for Lower Session Road, mainly because nandun yung majority ng mga business establishments and yung flock ng tourists. So this model shows the model developed in our software, yung NBMet. So for us to develop these models, we need to consider the main features present in our site. Yung building houses, balete trees in the median strip, yung pine trees natin, tapos yung roads natin, and other paved areas. So ito yung main features na kailangan natin ng data para ma-represent natin siya ng maayos sa model bago natin i-run yung simulation. So for the building or houses, nag-conduct tayo ng fieldwork inventory para makuha yung height ng mga buildings and also yung materials ng roof and ng wall. Yung supplemental source natin ng data is yung drone data. So in summary, majority of the building roofs were made of iron sheets, while for the walls, it is concrete. So as mentioned, we did drone surveys. In this example, we made use of EB, survey grade drone. Then we equipped it with a multispectral camera. So from this surveys, we derive data like this. So the DTM, DSM, and the surface height. So digital terrain model or yung height ng lupa or ng surface, digital surface model or yung height ng puno, ng mga buildings, at ng other features sa taas ng lupa. At pag binawas natin yung DTM galing from the DSM, makuha natin yung normalized na surface height or yung actual na height ng mga features like vegetation and buildings. For the balete trees, isa siya sa mga main features or unique features ng lower session road kasi meron tayong balete trees along the session road from the opening to the northern part ng or southern part ng session road. So for this data, we acquired the data using the inventory of the balete trees. We made use of supplemental data such as LiDAR and drone data. And we have identified or counted around 80 balete trees in the median strip. So dito makikita natin na gumagawa kami ng 3 models sa kada dimension ng balete trees. For example, pag may na-measure kaming 6 yung height and 5 yung width, ito na equivalent na model na ilalagay namin sa software. So bakit kailangan unique or may equivalent siyang dimension sa models? Kasi dito nakasalalay yung total leaf area density, yung kanyang shading capacity at yung kanyang evapotranspiration na efficiency. So unique yung ilalagay namin na models depende doon sa equivalent na measurement on site. So we also made use of technologies like this handheld laser scanning kung saan nakapagkuha tayo or na-scan natin yung kahabaan ng session road at yung output na data natin is yung point cloud data. So pag tinignan natin yung part na to, ito yung masasummed na visualization natin at pwede tayo mag-isolate ng single tree. So kahit nakauwi na tayo sa bahay after fieldwork, pwede pa rin tayo mag-measure kasi yung nakuha natin sa point cloud is actual measurement. So, for example, in this tree, yung height niya is 5.6, yung crown diameter niya is 6 meter. So, may cases na hindi dense yung nakuha na point cloud, kaya gumagamit tayo ng supplemental data such as yung drone-derived NDVI. So ito is yung normalized difference vegetation index. Pag nakapag-apply tayo ng enhancement sa visualization, pwede natin kunin yung canopy width. Similarly dito sa pangalawang photo. So pine trees naman, similar with balete, na mineasure natin yung height and trunk diameter on site. Tapos gumawa tayo ng equivalent na model para sa ating software or simulation software. So iba-iba, merong 15 yung height, 7 yung canopy or yung width, meron ding 19 yung height, 12 yung kanyang width. So meron tayong ginawa per model. Also, yung supplemental source natin is drone data. Yung pang-apat is yung roads and paved area kung saan ang data is mainly from PlanetScope map. Supplemental source is OpenStreetMap. And in summary, yung road is mainly made of asphalt, while yung pavements is usually made of concrete cement. So ngayon, punta na tayo sa mga future scenarios. If nakapag-Facebook kayo or nakapagbasa ng mga articles like this, I think nabasa nyo na yung sample articles like nag-prune ng balete sa Session Road, sa Malcolm Square, nag-prune din ng puno, and etc. So, if hindi ka familiar sa purpose talaga ng pruning, pwedeng negative yung implication sa'yo. However, well explained naman siya ng mga city planner na talagang may reason talaga yung pag-prune ng balete. For example, for safety purpose. Kasi pag sobrang lumaki yung mga branches, pwede siyang risk doon sa mga pedestrian and also yung mga commuters. So, kaya natin pinuputol yung puno para tumubo siya ng parang bonsai at hindi na masyadong lumaki yung kanyang mga branches. Second purpose na lang yung aesthetics. So, parang mas cute siya pag bonsai yung kanyang canopy. Okay? So yung sa second scenario natin, ano kaya yung epekto pag tinanggal natin lahat ng balete trees sa session road, sa lower session road? So instead na mag-prune tayo every 3 year to 4 years, what if tanggalin na lang natin para wag na tayo mag-prune kasi nakakapagod, ganun. So, ano ba yung difference between removal and pruning? Yung pruning kasi, meron siyang pinafollow na timing or schedule. For example, 1 day after pruning, ito yung itsura ng kanyang canopy. 1 year after, lumabas na yung mga shoots. 2 years after, nagkaroon na ng development canopy. And 4 years after, pwedeng back to normal na siya. So, 1 day after pruning to a certain months after pruning, pwedeng yung effect nito is equivalent sa effect ng removing trees. Bakit? Kasi parehas silang walang canopy, walang shading, and walang mechanism for evapotranspiration through canopy. So, yung scenario 2 natin, pwede niyang sagutin yung dalawang question. Number 1, what will be the effect in air temperature if we remove all balete trees? And pangalawa, what is the effect in air temperature within days to few months after balete tree pruning? So, yun yung mga target nating malaman with scenario 2. Ano naman yung scenario 3? With scenario 3, ito rin is more likely to happen in the future. So, removal of pine trees and addition of new buildings. So, pinagsama na namin siya kasi usually ganun naman yung nangyayari. Pag may bagong buildings na itatayo, tinatanggal natin yung existing na vegetation cover para mag-give way doon sa new infrastructure. So dito, sasagutin natin yung tanong na ano yung effects sa temperature pag nagtanggal tayo ng puno, ng pine trees, at nagdagdag tayo ng buildings. Ito po yung summary ng scenarios. Sa scenario 1, complete yung buildings, meron tayong 80 trees ng balete, meron tayong 243 pine trees. Sa scenario 2, halos lahat fixed pero yung balete trees tinanggal natin lahat. Yung scenario 3 naman, nagdagdag tayo ng 10 buildings at nagbawas tayo ng 30 pines, which is just 12% of the current pine numbers. So una, alamin natin yung distribution ng air temperature doon sa current scenario. So unang observation, ng pinakamainit is during 12 noon time hanggang alauna, which is represented here by this map. So obviously, siya yung pinakamainit among the 4 figures. So second observation, yung right portion daw, malamig siya during morning, yung 6 a.m. Pero siya yung talagang uminit from 9 to 12 hanggang halos 3 p.m. So bakit? Kasi dito, kung mapapansin nyo, yung density ng buildings is less compared dito. Mas compact yung buildings dito. Tapos, yung vegetation niya is scattered. At marami siyang open areas na paved yung surface. Therefore, mas mataas yung chances na ma-absorb yung heat and also mataas din yung retention ng heat. Okay? So yun yung main observation natin sa distribution ng land surface temperature sa lower session road. Ngayon, alamin natin kung ano ba yung effect ng pagtanggal ng balete trees sa lower session road. So unang tingin pa lang, makikita natin na as early as 9 a.m., pula na yung area na to. Similar with the 1 p.m., naging pula siya. Meaning, tumaas yung temperature up to 0.04 degrees. Sa 5 p.m., halos wala siyang nakitang effect. So let's focus on the 1 p.m. Here, again, we can see a localized increase in the temperature. Localized kasi hindi siya naramdaman sa right side, sa left side, pati na rin doon sa bottom side. So dito lang siya uminit kung saan tinanggal natin yung mga balete. So ano naman yung effect vertically ng pagtanggal ng balete trees? So dito, nakita natin na nagkaroon lang ng increase from the 0 height hanggang sa 2 meter height. So, very minimal increase halos doon sa 2 meter height. So, ito yung equivalent niyang range ng differential change sa temperature. Tapos, naramdaman lang yung pag-init sa surface from 10 a.m. hanggang 2 p.m. So yung maximum na increase sa surface is 1.6 degrees Celsius. So bakit nandun lang yung nasa 0 to 2 meter lang naramdaman yung change in temperature? Mainly because yung nabago sa temperature was attributed to the absence of tree shadow on the ground. So nung nagtanggal tayo ng balete trees, nabawasan yung shaded area doon sa lower session road. So kaya siya tumaas yung temperature doon sa height na 0 to 2 meter. Ngayon, ano naman yung effect pag tinanggal natin yung 25% ng mga pine trees, 12% ng mga pine trees doon sa lower session road, tapos nagdagdag tayo ng additional na 10 buildings. So dito, makikita natin na unlike doon sa effect ng balete trees, dito contrasting yung effect. Merong areas na bumaba, yung mga blue areas, at may areas na naging pula or tumaas yung temperature up to 0.3 level. So, varying yung effect niya, pero doon sa 5 p.m., halos wala tayong nakitang major na difference. So, focus tayo sa 1 and 5 p.m. So, unang observation, localized din yung effect. Kung saan tayo nag-add ng buildings, in this case, doon din bumaba yung temperature, mainly because of the cooling effect. So, yung mga areas sa loob ng bilog, siya yung mga nilagyan ng bagong buildings, at doon din sa areas nakita yung mga cooling or yung nag-cool down na areas. So, mga blue. So, yung cooling is hanggang minus 0.2 degrees Celsius. So, second observation, doon naman sa mga uminit na areas sa loob ng bilog, ito yung areas na tinanggalan natin ng pine trees. So, dahil wala na yung kanyang shading and also capacity for evapotranspiration, kaya tumaas yung temperature sa areas na to. Ngayon, ano naman yung effect vertically pag tinanggal natin yung portion ng pine trees and also nagdagdag tayo ng buildings? So, unlike doon sa effect ng balete trees, yung effect dito is extended hanggang sa 20 meter. So, from 0 to 20 meter, merong increase. Okay? So, ganun ba din, mas mataas din yung increase sa 0 hanggang 2 meter. Tapos, pinakamataas doon sa near ground na height, kung saan naramdaman natin yung pag-init ng surface as early as 8 a.m. hanggang 3 p.m. Okay. Sa human height na range ng temperature, naramdaman din yung pag-init from 9 a.m. to 2 p.m. So, yung maximum na increase sa near ground temperature is umabot ng 1.9 or almost 2 degrees Celsius. We also did some analysis in Upper Session Road. So, ito yung Upper Session Road from this area to this area. So, tapos, ito yung kanyang total model area natin na ginamit. So, ito yung main feature na makikita natin sa Upper Session Road, yung mall, na kung saan napabalita rin yung mga issues kasi nagputol siya ng mga puno para mag-give way sa expansion niya doon sa Upper Session Road. Maliban dito sa mall, makikita rin natin dito sa area yung madaming vegetation cover which is mainly planted with pine trees. So ito yung sample na 3D model ng ating site. So iba-iba yung equivalent na puno ng pine trees na tinanim, depende doon sa actual measurement natin on site. So ito yung mall, tapos nandito yung mga residential and other commercial establishments. So in summary, meron tayong two scenarios for the Upper Session Road. So scenario 1 is yung current scenario, meron tayong 460 pines. Yung scenario 2 is your adjusted scenario kung saan nagbawas tayo ng pine tree. So 345 pine trees na lang yung natira or 25% less than the original pine trees. So ito yung visualization ng model input. Ito yung para sa current scenario. Ito naman yung para sa less trees. Hindi siya visible kasi maliit yung puno. So let's visualize it in this figure kung saan yung green boxes tapos yung yellow boxes ang total niya is 460 na pine trees. Pero yung mga yellow boxes, siya lang yung tinanggal. So may total na 115 pine trees removed across the site. Okay? So tingnan natin yung effect pag tinanggal natin yung 25% ng pine trees doon sa Upper Session Road. So unang tingin pa lang mapula na siya, di ba? So 9 AM pa lang meron ng increase sa temperature or naging red siya. So nandito siya sa legend. Tapos at 1 PM mas lalo siyang pumula. So mas tumaas yung difference sa temperature at 1 PM timestamp. So sa 5 PM naman halos wala nang makitang effect doon sa Upper Session Road. So mag-focus lang tayo sa 1 PM na data. Again, yung areas is nagbago yung temperature. Pero kung saan tayo nagbawas ng pine trees, doon halos yung dominant na hotspots. So for example, dito nagbawas tayo ng madaming pine trees, mataas din yung difference sa temperature. So nag-increase siya even up to 0.4 degrees Celsius. Okay? However, I want you to focus on these areas here. Okay? So dito, halos wala siyang pine trees, di ba? Therefore, wala ding ibabawas na pine trees. Similar dito. Pero sa result natin, similar doon sa nabawasan na pine trees, dito tumaas din yung temperatura. Okay? So tumaas din yung temperature. So bakit? So dito makita nyo, napapalibutan siya ng tinanggal na pine trees. So papasok na dito yung effect ng wind direction and wind speed. Tapos, because of these factors, umabot dito yung increase sa temperature. Therefore, we can say na in Upper Session Road, removing 25% of the current pine trees will increase the temperature even up to the adjacent residential areas. So, hindi lang siya bounded or restricted doon sa mga green parks na pinagbawasan ng pine trees. So, because or based from these studies, here are the recommended mitigation measures for our planners and also for our LGU. So para sa pine trees, yung main impact na nakita is tumaas yung temperature, although localized yung pagtaas. Sa Upper Session Road naman, nung 25% na yung binawas, naging extensive yung increase sa temperature, so hindi lang siya restricted doon sa pine tree areas. So we suggest that we should preserve and protect the remaining pine trees in the city. Also, we should preserve the adult pine trees kasi they provide larger shading capacity and greater evapotranspiration efficiency. Also, planting of pine trees doon sa mga residential areas para ma-mitigate yung increase sa temperature. Sa balete trees naman, pag tinanggal natin yung mga balete trees sa Upper Session Road, sa Lower Session Road, ma-feel natin yung increase ng temperature sa kabuuan ng road na yon. So we recommend that we should continue the alternate pruning of balete trees following the right timing for pruning. Also, do not over-trim the balete trees to avoid large reduction in its shading and evapotranspiration efficiency. We all know na yung cooling effect ng vegetation is mainly due to the shading and the evapotranspiration mechanism that it provides and it undergo. So, as long as meron siyang canopy, pwede siyang mag-provide ng shading at pwede siyang mag-evapotranspire. Para naman sa continuous na building construction and expansion, yung main impact niya is napapataas niya yung temperature from the near ground hanggang sa average building height. So extended yung vertical impact niya. So although it provides cooling through shade in the morning, tall buildings hinder the release of heat during late afternoon to nighttime. Okay? So we recommend number 1, conduct monitoring and site assessment for newly proposed buildings. Pangalawa, regulate the conversion of green spaces into built-up areas. Pangatlo, we should explore conversion of buildings to green buildings. If hindi man siya kaya, kahit green wall na lang or green roof. So fourth recommendation, if possible, we should extend Project Puraw to Session Road in nearby residential areas. Malaki kasi yung tulong ng pagpintura ng puti sa roof para ma-improve or mapataas yung kanyang reflectivity at mabawasan yung pag-absorb ng heat. So for this recommendation, if mag-request yung LGU man, pwede naman namin i-run ito at simulate using NBMet para malaman natin yung specific na change in temperature, relative or absolute. Doon, pag convert natin yung roof into white roof or white painted roof. So, kailangan lang namin ng more time para ma-process natin yung data in case i-request nga yung simulation of Project Puraw in Session Road. Fifth is integration of GUHeat results to the city's CLUP. And number 6, consider using NBMet as an environmental impact assessment tool to simulate possible effects of future projects in the Session Road. So maliban sa NBMet, merong other microclimate simulation tools na available. Yung iba dito is, ang focus niya is on energy systems, yung iba is more on the wind systems. Yun yung kinagandaan kay NBMet kasi all around siya. So from soil hydrology hanggang building energy simulation, kaya niyang gawin yon. Also, tinitake into account niya sa kanyang process yung effect ng atmospheric dynamics, soil physics, and even vegetation responses. So, saan ka pa? Sa NBMet na. Although, of course, meron siyang bayad, so mas maganda kung ipa-purchase niyo siya ng through institution or through universities. So, hindi siya basta-bastang single user lang kasi syempre mahal siya. So, we have other recommendations other than the recommendations based on simulation. So, number 1, we identified growth in the LST hotspot, especially within the central business district. So we recommend to conduct monitoring and site assessment also. And number 2 is to utilize GUHeat build-up expansion map to detect the rapidly expanding area. So for the second one, actually na-request na po siya ng Baguio CPDO sa amin at na-provide na namin yung data. So nagbigay kami ng build-up expansion map from year 2012 to year 2018. So yung mga dilaw na areas dito yung na-expand during this time scale. Also, higher resolution to, so 5 meter compared to our usual na Landsat ng mga built-up maps na 30 meter. Okay. So, another one, in general, the similar trend in land surface temperature was observed between the on-site and satellite-derived surface temperature data. So, because of this, we can recommend the LGU to utilize satellite-derived maps to monitor land surface temperature levels, and we highly recommend na gamitin yung aming Google Earth Engine and QGIS plugin kasi user-friendly naman siya. Tapos mapapadali yung pag-generate ng mga land surface temperature maps pag ginamit yung plugin and or mga tools natin. Then, the variation of temperature of the different surfaces inside Burnham Park was studied. And we found out na yung surfaces like cream, concrete wall, water, soil, grass, and vegetation, sila yung surfaces na na-maintain niya yung lower LST throughout the day. Therefore, these materials must be maintained to help lower LST distribution within the park. Lastly, for our thermal comfort studies, the respondents feel cooler and more comfortable from late noon to late afternoon, in agreement with our simulation results. So this may suggest that all mitigation measures directed to solve the causes of increasing temperature in Baguio City will ultimately be felt by its residents and even by tourists. So those are the summary of our recommendations based on our scientific studies. This is the end of the second presentation, and I would like to thank you for your attention.